Just waiting for everybody to come back. I'd appreciate it if you guys go to ratemyprofessor.com and leave a review on there for me. Positive or negative, it's up to you. Leave what kind of review you think you're having so far. Usually this is something towards the end of the semester, but I'd like to ask you right now, because I'm going to try and ask people throughout the semester to do this. There's teacher evaluations at the end of the semester as well, and I encourage you guys to fill those out. Neither of these are mandatory, but it would mean a lot to me if you guys filled out some information on Rate My Professor. Just type in Rate My Professor Mo Niazi on Google, and I would greatly appreciate it if you guys left something on there. So I'm going to write that out. Hi, Kiana. Hi, everybody. Yeah, I know. I'm just letting people come in right now. Not everybody has made their way back in since the restart. I'm just asking you guys. It's not mandatory whatsoever, but I was wondering if you guys could go to ratemyprofessor.com and leave me a review on there. You don't have to do it, but if you'd like, you can. It's clearly anonymous, and you don't have to leave anything positive. You can leave something negative. It's up to you. You can leave something neutral, but I'd appreciate those reviews. RateMyProfessor.com is like kind of like an independent way to be able to attain some evaluations. And on top of that, at the end of the semester, there's also evaluations as well. So you guys can fill those out as well. None of this is mandatory, though. None of the evaluations are mandatory. But us professors, especially the ones that take their job seriously, we really like to see what people's opinions are and see how we can improve, because I want to know how I can improve. I'm always trying to improve. So I'd appreciate if you guys did that. But without further ado, let's continue on with lecture. Let's continue on with lecture here. Where did I cut off? Does anybody know where I cut off at? Oh, did I cut off at, I'm not sure where I cut off at. Did you guys get that slope is equal to y2 minus y1 over x2 minus x1? You had just drawn the orange lines from the lines. Yep. Okay. And you guys got this down, right? That slope is defined to be the change in y over change in x, which in math we call delta y over delta x. And we quantify it by the difference between the two numbers, y2 minus y1 divided by x2 minus x1. So without further ado, let's actually do a concrete example here. Okay? And I will note that this y equals mx plus b, this thing is called slope-intercept form. Okay, why is it called slope-intercept form? Well, it's because you're given a slope m and a y-intercept b. You guys will see more what this stuff means in here in a little bit. Okay, so let's say, first of all, let's graph a line. Let me give you an equation for a line. Let's say y is equal to, and I said f of x over here. Remember, f of x can always equal a y. Remember that. So y is equal to, let's say, 2x plus 1. Okay, let's graph this function. Recall, y is a function of x. So, and recall, the way that we graph things is we create a y of x, x table, or a f of x, x table. It doesn't matter. The letter doesn't matter. All it means is y of x is the output, x is the input. So let's pick some values. Okay, let's pick some symmetrical values about the origin. -2, -1, 0, 1, let's say 2. All right. This is still linear functions. Yes, Carrie. Yep. So, what is y of -2? Y of -2 is when I plug in a -2 for x over here in this equation. That's what we were doing earlier, remember? So this is 2 times -2 in the parentheses plus 1. Okay? What does this equal? So 2 times a -2 is a -4. Add a +1, we get the output becomes a -3. Next, let's evaluate y of -1. This equals 2 times parentheses -1 plus 1. Notice that this becomes a -2 plus a 1, which becomes a -1. All right. Next, let's evaluate y of 0. This is equal to 2 times 0 plus 1. 0 times any number is 0. Add a 1, you get +1. Let's evaluate y of 1. That's 2 times 1 plus 1. 2 times 1 is 2, plus 1 is a 3. Last but not least, y of 2. This is equal to 2 times parentheses 2 plus 1. That's 4 plus 1, which is 5. Next, that we've tabulated this right here, okay? And what I'm going to do here is under slope intercept form right here, I'm going to rewrite our function that we have here, okay? Y is equal to 1 plus 2x, all right? I've suggestively placed the 1 and the 2 underneath the y-intercept and the slope because 2 is indeed the slope and 1 is indeed the y-intercept. As you guys will see, as a direct consequence of us graphing by the method that I've showed you previously, okay? So let's put our -2, -1, 1, 2 here. And then let's put some values here. So we got a -3, -2, -1, +1, +2, +3, +4, maybe a +5 while we're at it. Okay. Now we go to our input, -2. We find -2 on the x-axis. Then we look for its output, -3, and we put a dot. And let's do this in yellow. Then we go to our input, -1. We find its output, -1. We go to -1, -1. We find that here and we put a dot. Then we go to the input 0. We find that the output is +1. So we go there and we put a dot. Then we go to 1. We notice that its output is +3. So we go all the way up to +3 and we put a dot. Then we go to 2. We see the output is +5. We go to 2, +5. We put a dot. Okay. Now what do we do to the dots? We connect the dots, right? If we connect the dots like so, we get what our graph is supposed to look like. It looks like a line. And that line, this yellow, is our y of x is equal to 2x plus 1. Notice that the y-intercept was at exactly where we thought. It intercepts the y at 1. This location for this dot is 0, 1, because the input was 0 and the output was 1. So that's why this number 1 is equal to the y-intercept. So why is that 2 equal to the slope here? How are we getting that the slope is equal to 2? Well, changing y over change in x is also kind of called rise over run. But it's kind of a bad terminology because your slopes don't always rise. Sometimes it drops. So rise over run is cool because it rhymes, but it's not always accurate. Okay, if you got a negative sign, it's not rise over run. It's like drop over run. So notice we have a slope of positive 2 because for every increment to the right, I go by 1. I go up by 2. 1, 2. Every increment, I go to the right by 1. 1. I go up by 2. 1, 2. So this 2 is equal to our delta y over our delta x. Okay. Notice we can discover that 2 by getting any 2 points on this function. Let's take this point right here and our y-intercept point. Okay. This point right here is, where is it? At 1, 3, right? So let's say, and I can erase this now, we've tabulated the results, so we don't need the table anymore. All right. So let's say our x1, y1 coordinate pair is equal to 0 and 1. And let's say our x2, y2 coordinate pair is equal to our 1 and 3. All right. Let's calculate slope. Even though we know what it is, let's show you why it's what it is. Okay. Okay. So y2 minus y1 is 3 minus 1. x2 minus x1 is 1 minus 0. Notice this reduces to 2 divided by 1, which is 2. Aha! That's why it's 2. The slope is 2 because y2 minus y1 is equal to x2 minus x1. And I know what you're thinking. Well, what if those 2 points were just really close to each other and that's why it worked? No, it works for any point on the line. Any 2 pairs of points on the line will work. Let me pick this far out point here, this -2, -3. And let me pick that far up point right here, this 2, 5. Notice that it will work again. So our x1, y1 changes to -2, -3. Our x2, y2 changes to 2, 5. Our slope is y2 minus y1 over x2 minus x1. Notice that y2 is 5 minus y1 is a -3. Be very careful to put parentheses and respect that minus sign out in front. Then x2 is a 2 minus, don't forget that there's a minus sign out there and respect that it's there. Today we've discovered why a negative is a positive. So we know that that breaks down to 5 plus 3, which is 8 up top. And this breaks down to 2 plus 2, which is a 4 on bottom. Wow. 8 over 4 is, you guessed it, 2, which is the slope. So it doesn't matter what pair of points you pick on the line, if you do y2 minus y1 over x2 minus x1, you will get the slope is equal to 2. Now, I will note, it does depend on what you say your first point and your second point is. If I switch this to be x1, and if I switch these guys, if this becomes x2, y2, x1, y1, the answer will change subtly. You're then saying it's going from here to here. You're saying the line is going from right to left instead of left to right. But all that would change is the sign. It wouldn't make it a 2 anymore. It would just make it a -2. Okay? So that's the only place where you could get some inconsistencies. So it's best to pick your first point to be on the left and your second point to be on the right. Okay, that's standard practice. So your x1 should be on the left. Your x1, y1 should be on the left. Your x2, y2 should be on the right. Because you're saying that the line is going from left to right. Okay. So given that the point 1, 3, and 2, 7 are 2 points on a line, come up with the equation of the line. Given that 1, 3, and 2, 7 are 2 points on the line, come up with the equation for the line. Okay? Well, given 2 points, what can we calculate about those 2 points? We just did it just a second ago. We calculated the slope. Well, m is equal to y2 minus y1 over x2 minus x1. Notice that this equals 7 minus 3 all over 2 minus 1. Because this is my x1, y1. This is my x2, y2. The slope. Yes, very good, Cody. So take a look at this equals 4 over 1, which is a 4. So that's what our m is. We know what our slope is. Okay. All right. So can we come up with the equation for the line? Well, so far that would give us y is equal to 4x plus b. We don't know b yet. How can we discover b? Truth is, we don't have enough information to discover b based off of just point slope form. Based off of slope intercept form. That was a Freudian slip. Based off of just slope intercept form, we don't have enough information. What we need is an equation that, given a point and given a slope, we could come up with the equation of the line. That's called point slope form. That is our y minus y1 is equal to m times the quantity x minus x1. So point slope form allows us to create slope intercept form given 2 ingredients, a point and a slope. We have more than enough points. We have 2 points. So pick whichever one you want. and we have the slope now, it's 4. I like to pick the point that has the smaller numbers in it, 1 and 3, so it makes the calculations easier. So I will then replace x1 with 1, and y1 with 3, and m with 4. Minus 1. Okay. So then what we're going to do is we're going to distribute this 4 here to each of these terms. So I get this is a 4x minus a 4. And then I want it to equal, like, I want it to look like this y equals mx plus b form. So I'm going to add this 3 to both sides. So I get y is equal to 4x. And positive 3 plus a negative 4 just makes a minus 1. Bada boom, bada bing. Take a look. We have it in slope intercept form now. And that means our b off of our mathematics there is negative 1. We've discovered that our b is equal to negative 1. So I can create the graph for this line now. I know that this graph will look like this. It's going to go through the y-intercept at negative 1. And it has a positive slope, so it's going to be slanted upwards. Where will it cross the x-axis? What is this point? My next question to you is, what is the x-intercept? Because recall, this is the x-axis, this is the y-axis. What is the x-intercept of this function? So what is the x-intercept of this function y is equal to 4x minus 1? So here's how you think about it. For all of the points on the x-axis, what are the y values? The y values are 0, right? Y is 0 here. Y is 1 here. Y is 2 here. Y is 3 here. Y is negative 1 here. But on the x-axis, y is 0. Yeah. So we can set y equal to 0 and solve for x to discover where this point is at. So I add a 1 to both sides. And I divide both sides by 4, and I get what x is. Aha. We have been able to pinpoint the location. This is 1. This is 0.5. That is at 0.25, which is the x-intercept. Looks like Carrie. Wow, math. That's right. Are these concepts that would always confuse you in the past but make sense now? Yes. That makes me very happy. Because I've grown more thanks to Mr. Niazi. Yeah. Thank you. Thank you. Thank you. I'm very proud of all of you and very happy for your progress and development. Keep working hard. You will be astonished at what you can achieve if you keep working hard. Hard work and dedication. It takes a lot of pressure to make a diamond. Okay? You guys are getting squeezed right now, but it's okay. You push back. Okay, so now we found the x-intercept. So don't forget, if it asks for a coordinate pair, it's going to be 1/4, comma 0. Because remember, all of the y's here are 0. Just like all of the y's here are 1, all of the y's here are 2, all of the y's here are 3, all of the y's here are -1. Okay? Big thanks. Makes much more sense now. Very good. Very good, man. I'm happy to hear that. It's probably stuff that was confusing for a long time. Hopefully it's not confusing anymore. Okay. So now let's talk about the different slope signs. Okay. I'm gonna draw slopes and you tell me what the sign is. What's the sign of this kind of a slope? Positive, negative, 0, complex. Is it an imaginary slope? Positive, yes. This is positive slope. Because as you go from left to right, the line goes up. Now, what about this one? What is the sign of this? Negative slope. Because as you go from left to right, the line goes down. What about this one? What about this one? This horizontal line. What's the slope there? No slope. 0. Correct. Okay. I mean, that just like makes intuitive sense based off of like what we even think of as slope in the English language, right? But notice that mathematically we can really understand why this is what it is anyways. So notice that this is my x1, this is my x2, this will be y1, then y1 and y2 are the same, right? So m, which is equal to y2 minus y1 all over x2 minus x1. If y2 minus y1 are the same thing, then anything minus itself is 0. So in the numerator, we get a big fat 0. Even though on the denominator, we may not get a 0. But notice 0 divided by any finite number is 0. So that's why the slope is 0. So not only does it make intuitive sense based off of what slope means to us in terms of the English language, but it also makes mathematical sense in terms of the definition of slope being the ratio of the change in y divided by change in x. What about that guy? Undefined? What? What do you mean undefined? You are correct. It is undefined. Okay. Notice that on any point of the line, okay, this is some x1, but okay, that's the same thing as x2. Even though I can find some different y1 and I can find some different y2, my slope equation is equal to y2 minus y1 all divided by x2 minus the x1. Okay, but notice that y2 minus y1 is a number that makes sense, okay? It's some finite number. But what about x2 minus x1? They're the same thing. This is the same location. Everything here on this vertical line has the same value for x. So x1 and x2 are the same. So anything minus itself is 0. Uh-oh, SpaghettiOs. We're dividing by 0. X 0. Yeah. Why is it bad to divide by 0? We discussed why division by 0 is bad, right? It's undefined. It leads to logical inconsistencies in the mathematics. I'll have you know, though, that you can divide by 0 in more advanced math classes, as long as you define what you mean by dividing by 0. So if you want to go become a mathematician one day, you can actually define what it means to divide by 0. It's undefined based off of mathematics at this level. You can create higher level mathematics that division by 0 is defined. Matter of fact, we're gonna have to do that if we're gonna discover how black holes work, because black holes are basically like dividing by 0. Yikes. No, you mean you're excited. So now you know why a vertical line is undefined and why a horizontal line, thank you, baby doll, and why a horizontal line, oh, it's hot. No, I like cold. And so a horizontal line, now you know why it has no slope mathematically, not only intuitively, but mathematically. Make sense? Make sense? Good. Finding slope, we did that. Let's see here. Math is just wow. That's right. Math is really cool when you understand it, right? When you don't understand it, it's really annoying and it's really frustrating and it doesn't seem cool. It just seems like, it just seems nonsensical. All right. Let's do it seems like a black hole of confusion. Ha 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 ha. Good one. Good one. Here's what I mean by why black holes are like dividing by 0. I'll just tell you real quick. Density density, the quantity density is mass divided by volume. Okay. So what happens when a black hole forms is you don't get mass changing. What you get is volume changes. Volume goes from being very big to almost zero. It goes from being very big to almost zero. So even if you have very little mass, if the volume gets really small, you get mass divided by zero, which means density equals, technically, it means density equals infinity. All right? So the density of a black hole becomes infinite. And that's why a black hole is like something in which we never interact with in our everyday life, because nothing in our everyday life has infinite density. There's things that have more density than others, like metal has more density than water, and wood has more density than paper. But 3 minutes, gotcha. But infinite density, we don't interact with stuff that has infinite density. And so it's very difficult to have an intuition for what does it mean to interact with something that has infinite density. But that's what's actually happening. And I like to tell this to people because it's really cool. The way in which we can turn the planet Earth into a black hole is if I got everything in the Earth and squeeze it into a sugar cube, like this big. If I squeeze the entire planet Earth into something the size of a sugar cube, probably something the size of this piece of chalk. If we could squeeze the whole planet, I mean everything, all the mountains, all the cars, all the oceans, everything on this whole planet, if we could squeeze it into this size of this piece of chalk, our whole planet would turn into a black hole. That's really cool. Yeah. Yeah, I tried to squeeze the whole planet and it wasn't working. Because every time I try to squeeze the planet, it pushes me back. It won't work. Let me try one more time. Nope. I'm not strong enough to squeeze the whole planet into a black hole. One day, maybe. So maybe one of you at home will come up with the mathematics of how to divide by zero properly. I'll race you. Eat more cheddar. I definitely need to eat more cheddar if that's one of my goals, is to crush the whole planet into a black hole. I'm gonna need a lot more cheddar. So let's say we have a function f of 3 is equal to -2. And then let's say we have f of 8 is equal to 1.